Welcome back to section 3.1. Alright, there are a few interesting situations that we need to talk about when solving by graphing. So I got a couple problems here, a couple more I want to do. 2x plus 4y equals 8, negative 3x minus 6y equals 12. Once again, if I'm solving this, I'm not going to get y all by itself. I'm just going to build myself a little table. I'm going to plug 0 in for x here. Y would have to be 2. And then I'm going to plug 0 in for y. X would have to be 4. So I've got 0, 2, and 4, 0. Grab my ruler, connect my dots. And then I'm going to do the exact same thing for the red line. Plug 0 in for x. Y is negative 2. Plug 0 in for y. X has to be negative 4. So I have 0, negative 2. And I have negative 4, 0. And something interesting happens. Well, at least I think it's interesting. What's supposed to happen there, no, doesn't quite look it. I must have missed my scaling a little bit. Those two lines are supposed to be parallel. They never cross. And that happens sometimes. So we have parallel lines. So when do they cross? Never. So our answer would be no solution. Or the fancy math word you will see for no solution is inconsistent. Okay? So especially if you're doing your homework online, it will say solve or show the system is inconsistent. And by inconsistent, they mean parallel lines. They don't cross. Okay? And when it comes time to take a test, my directions will be solve the system or show that the system is inconsistent. And you'll need to know that inconsistent means no solution. Alright, the other interesting thing that can happen, let's try this one. Alright, the first one, y equals 2x minus 5, that one's easy enough. We've got intercept of negative 5, slope of 2, so up 2 over 1, up 2 over 1. Grab the ruler, connect the dots. Alright, and then the second one I'm going to draw in red. Let's see. So if x is 0, y is going to be 15 divided by negative 3 is negative 5. And if y is 0, this one doesn't work out so hot, but we can live with it. We get 15 over 6, which of course we could reduce by 3 to be 5 halves, which is 2.5. So I have 0, negative 5, and then I have 2.5, 0. So something interesting happens. Well, again, I find it interesting. I get the exact same line. And that can happen. Sometimes when I give you two equations, you can have the exact same line written in two different forms. Okay? So here we have the same lines. So there are an infinite number of solutions. Every point on the line is a solution, and the fancy math word for that is dependent. So again, when it comes time to take a test, the directions would be solve the system, or show that the system is inconsistent, or show that the system is dependent. So you're going to need to know when you get this picture, one line on top of the other, you're going to write the word dependent for me. Okay? Alright, some homework problems for you. Here are two more problems I want you to do. So go ahead and pause the video now and take a look at those two problems. The last thing in this section, when I took algebra, I took it quite a long time ago, the graphing method was not very popular. And the reason the graphing method was not very popular was, going back to this example we did here, the graphing method works really nice as long as the answer falls right on a corner of your graph. So if x is 2, y is 3, that works great. If your answer has x to be some decimal or some fraction and y to be some decimal or some fraction, it's very difficult to solve by graphing. So graphing was not a very popular technique back then. Today, graphing has become a very popular technique in large part because of the graphing technology. So let's say I want you to solve y equals negative 2.51x minus 6.49 and y equals 1.74x minus 1.75. Alright, those would be difficult to solve by graphing if I'm graphing by hand. Fortunately, I don't have to graph by hand. I have a calculator. Okay, so we're going to use our calculator to solve systems of equations. So I'm going to go to y equals, and I got some junk in here that we don't need. Let me just clear that out. Okay, this is a little bit difficult to see. Let's see if I can change the brightness a little bit. That's a little better. Alright, so I'm going to type in my two equations. Minus 2.51x minus 6.49 and 1.74x minus 1.75. I definitely know these two lines are going to cross. I know they're going to cross because I see they have different slopes. Alright, let's draw zoom 6. Oops. I hit the wrong button there. Zoom 6. Alright, so we can see where they cross. Cross right about there. Now the beauty is the calculator will give us a very accurate answer of where they cross. And the way you do that is you go into this calculate menu right here, which is up on the same button as trace. So I go second, calculate, and I want to do number 5. I want to find the intersect. So I hit enter. It asks me, so you notice up here it writes down the equation. It says, is this the first curve you want to use? Is this the first equation? And my answer is yes, so I hit enter. And then it should jump to y2, and it asks you, is this the second equation? Is that the one you want to use? Yes, I hit enter. Students sometimes wonder, why does it ask that? Well, because it's possible to have more than 2 equations typed in. And maybe you want the answer for a specific 2. Maybe you want the first one and the 5th one if you have 5 all typed in. Alright, anyway, now it asks us for a guess. So I use my arrows, and I get close to my answer, and I hit enter, and it finds it. So my answer for this would be, I gotta pick up the calculator so I can see it a little better, x equals minus 1.115, y equals minus 3.691, rounding to 3 decimal places. Alright, so we could write that as a point if we wanted to also, minus 1.115, minus 3.691. Alright, so your last 2 homework problems. Homework number 5 and homework number 6. These two solve using your calculator. Y equals 5.437x minus 2.136, and y equals minus 2.752x plus 3.984. So there's number 6. And finally, number 7. I'm sorry, that was number 5. Here's number 6. 4x minus 3y equals 13. And 2y plus 5x equals 4. And of course for number 6, in order to use your calculator, you are going to have to get y all by itself, because that's the only way we can graph in our calculator is to have y all by itself. Okay, turn those in when you come to class, and I'll have some more work for you to do.